Earlier this month, the ISO C++ Standards Committee met in Issaquah to put the finishing touches on C++ 23 and voted into the standard. But have you ever wondered how we get an updated standard every 3 years? And who are the people that make the decisions on what goes into each new standard? And now that C++ 23 is headed out the door to a compiler near you, what's next for C++? We'll talk about this and more on today's episode. I'm Matthew Butler, and this is Exploiting Modern C++. C++ is the world's most popular programming language. It's used everywhere: embedded systems, the web, financial systems, high-end computing, and gaming. Millions of developers have written billions of lines of code that run on everything from airplanes to power plants to medical devices to spacecraft to the banks that hold your money. And every 3 years, the Standards Committee adopts a new standard. As we say in the committee, our trains run on time. Every third year, a new standard. But how do we get an updated standard out every 3 years? C++ got its start in 1979 with C with classes. By 1985, the first C++ book was released by Bjarne Stroustrup, giving us the language and patterns such as RAII. By 1990, the annotated C++ reference was released, becoming the first de facto standard for the language. 1990 also marked the founding of the ANSI C++ Committee. The first C++ committee meeting happened in Somerset, New Jersey. By 1991, the second edition of the C++ programming language was released, and the ANSI C++ Committee became the ISO C++ Standards Committee that we have today, making it an international organization. 1992 would bring the STL. 1998 brought us C++ 98, which added template metaprogramming to the language. In 1999, the Boost library was created by committee members to produce high-quality features as an incubator for the standard. Vocabulary types such as any, variant, and optional, string view, and the file system library are just some of the features that we use today that came from Boost. C++ 11 ushered in the modern age of C++. It gave us lambdas, auto, smart pointers, and zero overhead abstractions, among other things. It brought the C++ standard to a whopping 1,300 pages. And C++ 11 revolutionized how developers would use C++ and how they design software. C++ 14 would generally be a service pack for C++ 11 with a few new features, but it was mostly a defect fixes for C++ 11. C++ 17 would once again bring us a significant update to the standard, this time adding expanded const expr, tuples, string view, optional, new memory management, and new algorithms. It was the largest update to the standard since C++ 11, bringing the standard up to 1,500 pages. C++ 20 would once again be a major update to the standard. It gave us the spaceship operator, designated initializers, ranges, new attributes, coroutines, modules, and most importantly, concepts. The standard would balloon to 1,800 pages, adding a threading library, nearly a dozen new headers, and library features such as span, formatting, and feature test macros. So where does the 3 years come from? It's no great mystery. 2 years was too short, and 4 years seemed to be too long. And if you've been paying attention, you've noticed that the number of people attending ISO meetings has greatly expanded. But that was about to change.
COVID-19, the disease that defined our lives in 2020.
2020 is now the deadliest year in U.S. history.
Since late March, the U.S. has led the world with the most cases and the most deaths, now at more than 334,000.
COVID killed millions worldwide, while sickening hundreds of millions. And it rearranged our lives. The ISO committee would begin meeting by Zoom and try to carry on as normal, just like the rest of us. C++ 23 followed in the footsteps of C++ 17 with a few features, but mostly defect fixes. It also marked the second time that the committee has met in person since COVID. C++ 23 also marked a change in the ISO community. The lower turnout was partly because a third of the ISO committee still attended by Zoom. But the ISO organization also began enforcing the rules restricting attendance at ISO and the study groups to members only and invited guests. While these may have been the rules, they had never been enforced until this year. And if you don't have the $1,300 to join the ISO or a company that will front the money for you, you can only attend one meeting as a guest and then not at all. This cuts the committee off from a lot of talented engineers who have good ideas about how to simplify and expand the language. Still, if you want to participate, there are two ways to do it. You can join the C++ Foundation or the Boost Foundation, which will make you a member of the committee. Both of these are free of charge, and I highly recommend them. But something else was different about the Issaquah meeting. In 2022, the White House released its open-source software security mobilization plan. Besides being a mouthful, the plan targeted C++ for the first time. Depending on whose numbers you use, between 70 and 90% of all vulnerabilities are memory safety vulnerabilities. And C++ is the king of memory safety vulnerabilities. So the White House's response to this? They recommended that companies stop using C++ and move to Rust or some other memory-safe language. This was quickly followed by the National Security Agency, and even the people who tell you what kind of toaster to buy, Consumer Reports, piled on. What had been on the EU's radar has come home to America. It's got the ISO committee's attention. At the Issaquah meeting, software security became a first-class issue for the first time in ISO's history. It now even had its own study group, which brings us to how the ISO committee creates the standard. The ISO committee is made up of representatives from national bodies from around the world, and companies across the U.S. such as Microsoft, Adobe, AMD, Apple, Bloomberg, Google, Intel, NVIDIA, and most of the national labs. Right now, there are about 250 voting members. Proposals from the standard generally start life in the study groups. That's the group of large green blocks at the bottom. SG21 is currently designing the new contracts feature, which will hopefully drop in C++ 26. SG22 is tasked with maintaining compatibility with the C standard. Yes, there is an ISO committee for C called WG14. From there, proposals go to either Core Evolution Working Group or Library Evolution Working Group. Most proposals will be looked at by multiple study groups, and in Evolution or Library Evolution multiple times. Depending on how big the proposal is, how much work it needs, and how many groups look at it, it can take 3 years or longer to get approved into the standard. SG17 and SG18 are the incubator study groups that work on less developed proposals for the language and the STL. Evolution and Library Evolution are the final gates before going to wording. This is where the language lawyers work over the proposal's wording to make sure that it fits the standardese. When I attended my first committee meeting, I sat in for an afternoon in core wording. It was like watching Franciscan monks copy the Bible. The room was so quiet it was hard to stay awake. Occasionally someone said something in the standard's legalese, but mostly they just worked in silence. And yet these are the smartest members of the committee. What you have to understand about the C++ standard is that it's not made for you and me. Try as I might, I still have to get help trying to unravel the rules in it even after 5 years of study. And that's because the standard is written for compiler writers, not for us. Which explains the legal language and how we got terms such as subnormal values, deduction guides, capture defaults, and past the end values. After making it through wording, the proposal is voted on by the entire ISO committee. Once we produce an update, wording goes through it, making minor revisions and fixing issues with the standard. From there, a CD is cut of the new standard for various nation bodies to review and comment and vote on the final version. That part takes almost a year. The 3 groups on the top left are the Directions, Admin, and ABI review groups. The Directions group sets the general course for the language. It's made up of committee members who have been part of the ISO committee for decades. The ABI review group looks at when or if we break the ABI and how badly we'll do it. And the Admin group handles the Herculean task of putting together the 3 plenaries a year along with managing the flow of information that makes the committee work. The C++ standard is legally the property of the International Standards Organization. Even as members, we don't get a free copy of the standard we've worked on. We have to pay just like everybody else. But you can get access to the drafts, including drafts that are very close to the published standard and the papers that went into them. We'll talk about that at the end. But let's go back to security. In 2020, I proposed the Safety and Security Review Group at the level of the Directions and ABI groups. SSRG was an invitation-only group designed to study the security outcomes of proposals working their way through the committee. This last year, after security was pushed to the top of the list, the SSRG was promoted into a study group, giving it a wider range of proposals that it covered. It will now help drive the security updates to the standard, and this is good news. I did an interview with CPPcast 4 years ago where we talked about safety in the language. You can find that interview on my channel. I made the point that if we didn't do something to address the safety of the language, companies would ultimately phase out C++ in favor of other languages that are perceived as safer, like Rust. That move would be triggered by government regulation, the risk of breaches, and the legal penalties that follow. That's happening now, and the Standards Committee has taken notice. How far it goes remains to be seen. So what's in C++ 23? As I said before, C++23 is mostly a service pack for C++20. Besides defect updates, it includes the stack trace library that gives us call sequence information for debugging. Expected is a new error reporting mechanism that can return any type or an error. Print integrates the new format library with standard I/O facilities. MDSpan is a multi-dimensional array view. Flat map and flat set are drop-in replacements for map and set, but with better time and space complexity. A multi-dimensional subscript operator gives us Fortran-like syntax for arrays. The assume attribute is a portable replacement for built-in assume in Clang and GCC and assume in MSVC. And monadic operations for the optional feature from C++17 have significantly improved its syntax. I promised you that we would talk about how to get draft copies of the standard and the papers that go into them. To find the latest working drafts, visit the GitHub repo C++, pick the public project draft, and then look at the papers. To find the current set of proposals, visit the hyperlink on the screen, wg21.link/index.html. These two sites will give you most of what the committee is looking at. On the surface, C++ provides some interesting additions to the standard, but to me the real story of Issaquah is that security has now risen to the top of the priorities list. Jerry Davis, the former CISO of NASA's Ames Research Center, once said, "The software industry is really one of the only organizations where you can knowingly build a defective product and push it out to a potential buyer, and the buyer assumes all the risk." That used to be true. But the US government, and the EU government in particular, are already moving to hold software vendors responsible for the failures of their products. And from a CISO's perspective, moving to a quote-unquote safer language like Rust is an easy decision. This leaves C++ with a very large target on its back. Do I think that the committee is going to completely shift its focus to security and start making security the benchmark for every new proposal? No. And there's no going back. You can't unring a bell. And we can't start throwing out the most dangerous parts of the language to get a safer language. We did that in the 90s and called it Java. But what the committee will do is to take the security outcomes of every new proposal into account while developing the language updates. Still, old habits die hard and not everyone is fully on board with the new reality. What we will do is focus more on education, tooling, and efforts like the core guidelines to make the use of the language safer even when we can't make the language itself safer. This will put the onus on developers who write the code to make sure that they're making good security choices. As far as the language, C++ still has a lot of life left in it, and the reports of its demise are greatly exaggerated. I'm Matthew Butler, and this is Exploiting Modern C++. If you'd like to learn more about the origins of C++ and how the features that we have in the language today came into being and why they're there, pick up a copy of Bjarne Strusup's book, The Design and Evolution of C++, sold at fine booksellers everywhere.